Okay. So before we start with the lecture today, there will be a short briefing by CIT on the use of the Exemplify software. We will use the Exemplify software for our midterm as well as the remaining assignments that we have. Okay, so it will be also good if you take out your laptop to follow this. Right? Do you need them to open it?
If they have.
Okay, so yeah.
Nice.
So if you have your laptop, just open it so that you can probably follow the briefing.
How do I switch it? Let me try VGA. I think should have it. Oh, it's under laptop one. VGA. Alright, cool. Did they use this last year?
Last time.
Last semester they did. Okay. So it's not a new thing for them, right?
No, but these are new students also.
Oh, okay.
We only use it in this module.
Oh, okay. Hi guys. So probably settle down and get ready with your laptop if you have. Otherwise, you can do it at home. Don't worry about that. Okay. So before we start, probably you want to take note or jot down this web link because all the troubleshooting guides and instructions are all in this wiki page. So in the event if you encounter any issue on Exemplify installing or in the midst of examination you have any issue with it, you can refer to the link. Okay, don't worry, I'll come back to this slide later. So to get use Exemplify on your laptop, please always check whether your laptop meets the system requirement. So for Windows user, Windows 10 and 8 are not supported anymore. So anyone using Windows 7 and 8, please do upgrade your OS to Windows 10. And where for this Mac OS, only 10.11 and above are supported. Alright, so current latest one is Mojave 10.14.6, I guess. Alright. So, however, you can always try the practice exam available in the Exemplify. So, if it works, it's okay. So, don't upgrade your OS anymore before the exam. Alright. Otherwise, if your Windows OS release any beta or any newer version before the examination, please don't upgrade. Okay, otherwise you'll have technical issue during the examination. Always set your laptop default language to English, especially your keyboard, alright? So if you have any essay question in Exemplify, to answer in English, please set it in English first before you start the exam, okay? So if you don't know how to do that, you can refer to the link here, okay? Whereas for Mojave OS user, there's a function for you to switch your Mac OS appearance. I believe most of the Mac user they know. Okay, so some of you might prefer in dark, okay? But Exemplify only supported in light mode. So before your exam, please change it to light mode first. Then you launch Exemplify. So after the exam, then you switch it back. There's a instruction here, so you can refer to the link here. Alright? Wireless accessories are not recommended. However, if you really need them, please do pair them first before you start Exemplify. Okay? We always recommend the wired one, the traditional wired keyboard and mouse if you really need them. But if you pair them and you run Practice Secure Exam, and if the wireless mouse works, so it's okay, you can bring it to the exam venue. Alright? So this is the way to download and install Exemplify. So in the event, if you haven't downloaded to your computer, please do so. You can go to examsoft.com/NUS, click on the login button under exam taker, log in with your NUSNet ID and password, then click download, then install accordingly. And this step number 6 is actually for Windows user. If you have any third parties antivirus or Windows Defender, please do create an exclusion within the antivirus software. We'll say that the antivirus will not interrupt with Exemplify. Alright? So if you don't know how to do that, you can refer to the link, or you can bring your laptop to me later after the briefing. Okay, so once you have installed Exemplify, launch it, and you'll be prompted to register. Type NUS on the text box, wait for the drop-down list. So if the drop-down list does not appear, please check the internet connection. Alright, so in the drop-down list, select NUS APAC, Asia Pacific, and click Next. And you'll be brought to this NUS login page. So if you have logged in earlier before, it will show you one green confirmation message. So you can go back to Exemplify immediately. Otherwise, you just need to type in your NUSNet ID and password again. Okay, so once you have logged in successfully, you'll see a list of NUS standard practice exam. So do the secure practice exam at home to test whether Exemplify runs smoothly in your laptop. Alright? And also to familiarize yourself with Exemplify. So always click on the practice exam and click download. So during the download, internet is required, okay? Otherwise you will have some error. And the password for all the practice exam is the same, which is password 1. Okay, you may jot down somewhere. And you can try the practice exam as many times as you want, okay? Alright, so once you have typed in the password, you're prompted with this notice. Okay, exam notices, read it carefully, and click Next. So once you have given green light to start during the examination, check off the box and click Start Exam. So during the examination, Exemplify might hang or you have any technical issue, right? So whatever you type, it doesn't appear, or your mouse cursor stuck somewhere, it doesn't move. Don't worry, you can turn off your laptop entirely by force shutdown. Press on your power button, hold it for 10 to 15 seconds until your laptop is completely off. Then turn it back again. So once you turn it on, wait for Exemplify to load. Okay. To resume your exam, a resume code is required. So in the exam hall, raise up your hand and the invigilator will give you the resume code. Wi-Fi is not required during the examination. So in other words, Wi-Fi is only required for you to register, download the exam file, and to submit the exam file. So don't worry about that. If your exam is run in secure mode, Wi-Fi will be cut off, alright? Timer for your exams only starts when you see the first question. Okay, so some of you might take a while, a bit longer to load Exemplify. So don't worry, you'll still have your own timer when you see the first question. So don't worry if your colleague or your friends beside you starts the exam first. Don't worry, because you still have your own timer. Exemplify always auto-save your answer. Don't worry. And no time loss if there's a troubleshoot on your laptop. As I said earlier, if Exemplify hangs and a reboot is required, don't worry, because Exemplify always stop and save when there's any technical issue. Even when you restart, the timer will stop. Alright? Okay, this is just for your information. If there's any examination that is run in sequential mode, means say that you cannot go back to previous question if you proceed to next. So just take note, do not use those shortcut key, just in case you accidentally press. If you press next, then you are not able to go back anymore. Okay, so let me quickly bring you through this Exemplify. Okay, so this is the dashboard, the page after you log in. Always check this is your NUS ID. Alright, if it's not yours, please do check and log out and log in again. Alright, otherwise you are taking the exam for your friends. Okay, so these are all the practice exam. So to download your exam actual paper, you can click on this refresh exam list, but you need to know when the exam is available for download. Okay, so today we'll try this. Okay, I'll try this non-secure with internet and suspend. If I do it, the secure exam, the projector screen will be cut off, alright? So download the exam file. These are all the exam settings for my assessment. So my assessment is non-secure. I have 1 hour for this paper. My Wi-Fi is on, means I can access internet. Navigate is on, means it's not sequential. I can toggle to any question that I want. So the rest of the exam settings are here. So spell check is on, copy and paste is on, means say that there is essay question in this assessment. Right, calculator is available, highlighting, as well as backward navigation. Okay, so the actual password for your exam will be given probably 5 minutes before the exam. So depending on how the invigilator runs the exam. Okay, so password 1, and I click start exam. Exam notice, and this message is telling me that there's exam attachment on this assessment. So this attachment is actually kind of cheat sheet or a formula sheet for me to refer for the entire assessment. Alright, so check off the box and click start exam. Alright, okay, so this is the assessment title. Always check if you are doing the correct assessment. And this is your NUS ID, and this is your NUS ID, and the main time remaining I have. So this paper is only 1 hour, so I only have 59 minutes left. So do take note, this is hour and minutes, no seconds indicator. Okay, so under exam controls, you can view exam attachment. So this table, I can view it anytime I want. Okay, throughout the assessment, I can zoom in and zoom out. I can drag it here and I continue my assessment here. Okay, if you want to view it again, you can click on it. Otherwise, you can close it. Exam notices, if you wish to read again. Okay, this is hide exam. This function is actually for you to hide your answer if you go to the washroom in the midst of examination. Take note, if you hide your exam, the timer will be still running. Okay, take note of that. Then, okay, suspend probably will not be available for NUS main examination. Submit exam. So this button is actually for you to submit exam when you are done. So if you have accidentally clicked it, don't worry, you can return to exam as well. But if you click on close exam, it will bring you to this page. So take note. If you want to go back, click on this return to exam. Otherwise, if you check this box and you click submit exam, no more U-turn. Okay. Alright, so let's come to these toolkits. Under tools, various colors of highlighter, if you wish to highlight some of the important words on the question text. Time remaining, okay, you can refer here as well. I have 57 minutes left with the second indicator here. And this is 5 minutes countdown timer. As you can see, this countdown timer is actually in 5 minutes in advance. So it will actually ring you at the last 5 minutes. If you want to add your own alarm, you can add it here, 5 seconds. Okay, it will start counting down in 5 seconds. Okay, what happens is it will just notify you. Okay, just click on it to dismiss. adjust text size if you want to have a larger text size of the question text. Okay, if you want to make it smaller, you can drag it. Attachment and notices are the same as the one you see here. All right. Okay, so if you don't want to use these two key, you can actually click on these to close them. Otherwise, you can click again to use. Question attachment. Question attachment is actually different with the exam attachment here. All right, this exam attachment I can view it throughout the assessment, but for this question attachment, I can only see on this question 1. All right, it will not appear in question 2 and onwards. Okay, so the same, you can actually zoom in and zoom out. All right, it's the same, straightforward. Calculator, straightforward if you need them, and notes. All right, so this note function is actually for you to organize your wordings. So do not type your answer in these notes, because your examiner will not grade anything you type in notes. Okay, this is just for your reference. Okay, so back to this question. So in order to select the answer, just click on the bubble here. Okay, and the software will tell you that currently you have selected A. Okay, if I select C, okay. And this eye icon is actually for you to strike off those impossible answers for your reference. So you can ignore if you don't want to use them. Okay, it's just for your reference as well. Okay, next, essay questions. So some essay questions will have character limits. So while I'm typing, see the character number increases. Okay, until I hit the limits, then the software will prompt me. So you can always click on this box to check how many words, how many characters you have typed. Okay, so one spacing or any punctuation, consider one character as well. Okay, close this if you want to see them. So some question texts are very long. If you want to have more space to type your answer, you can click on this arrow icon to hide the question text. Okay, to see them, you can click on this. Then this flag question is actually for you to flag your question if you want to come back again. Okay, so for example, I know flag this so that I can come back later. Okay, so then I continue to this. Okay, so under this filter function, I can filter only flag questions so that it shows only those questions that I flagged. Okay, or you can filter those unanswered questions as well. Or you can filter answered question. Okay, I'll show all. Okay, and you can full use all kinds of like copy, cut, and paste function that are available here as well. All right. Okay, so to toggle within the question, you can click on the bubble icon here. Otherwise, you can click next and previous. Okay. Right, let me see what else. You need to take note of this. Yep, that's all. Okay, so once you have done, okay, let me answer everything. Okay, let's say if I miss out question 8 and I accidentally click submit. So this message will tell me that exam incomplete, means you haven't finished answering all the question. Okay, so return to exam. If it's too long, I can filter to unanswered. I only have one. Okay, so answer this. Then I'll click submit exam. All right. So once you're done, check off this box and click submit. Okay. So at this moment, Exemplify will try to reconnect to the internet. So it might take a while. Don't worry if it's taking too long. As long as the loading icon here is spinning, it's okay. Just let Exemplify submit. Okay. Okay, so while waiting for this, I'll go back to my slide first. Okay, this is what you have gone through earlier, submit exam. Okay, so in the examination, please make sure you see this screen after the submission. Okay, this indicates that my answer has been successfully submitted to the server. Okay, I'll close this. Okay, this is the loading part. Okay, so, yep. As I mentioned earlier, always make sure you see this green confirmation screen. Okay, so sometimes you might see this exam complete, but you see this Wi-Fi icon here. You say that your laptop is not connected to the internet, so check the connection and click on retry upload. Okay, so once you have uploaded the file, you'll receive an email from ExamSoft as well. Okay, don't worry, there'll be double confirmation. One is a green confirmation screen, another email you'll receive. Okay, so things to note before the exam, especially your midterm and final. You're only allowed to download one copy, so please download Exemplify, the exam file, to the correct laptop and bring the correct laptop to the exam venue. And if you have downloaded the file in the laptop A and somehow your laptop A crashed, your keyboard not functioning, you still need to bring the spoiled laptop to the exam venue as well. So we'll help you to troubleshoot, we'll remove the file, and probably we'll provide you the spare laptop, okay, if you want to use our spare laptop. Otherwise, you can bring your own spare laptop as well. And if you're not feeling unwell, if you're feeling unwell and feel like not taking the exam, do not download the exam file, okay? And always fully charge your device and bring your charger to the exam venue, okay? For Windows user, disable Windows Update right before the examination, okay? If you have added the exclusion to your antivirus software, you can ignore this disable antivirus software before the exam, okay? So if you're unsure, you can see me later. Always remember your NUSNet password. This is very important because only you yourself can reset your own NUSNet password. Otherwise, you'll need to approach IT Care for this. And register a mobile number in the NUS EduRec system in the event if you need to reset your password in the exam venue on the spot before the exam. Okay, refer to the link if you need. Okay, don't worry, these slides, you can download this slide from the wiki link as well. I will show you later. Okay, so if you need any technical help or you have any questions about ExamSoft or Exemplify, feel free to email us at CIT Box 25. Any other password related issue like your NUSNet password, you need to approach IT Care. Okay, so always refer to this link. You can download this slide from the link as well. Okay, I'll put on the link again. Okay, so any questions? If you want to show me your laptop or you have any question, you can approach me later. Okay, thank you.
Okay, so that's a. Oh, can I? Yep. Where can I get the slide? Maybe I can upload it to the Luminous as well. Yeah, sure. Yeah, so I will also upload the slide to the Luminous so that you can also see it again later. Okay, so remember that we're going to use the Exemplify software for our midterm, final, and the assignments. You have 3 more assignments for this. Okay, before we start with the lecture, some of the students one student was asking me, why is it called relational database? Okay, so I was looking into this, and the answer might actually surprises you. The reason why it's called relational is because there's this notion of, first there's a notion of function. So you remember from last week we have function. So if you have a function f, given the value of x, you get y. Okay, which means that you can actually write it down as that x is an input, and y here is an output. In the case of predicates, so instead of a function, you have a predicates with x, and let's say it's y here. The return value is always true or false. Okay, so we say that xy is in a predicate if the result of the predicate is true. Yeah, and in this case, both x and y are inputs. Now, in the case of a relation, this is only used in one other programming language that I know of, which is Prolog. What you have is a relation such that x here and y is either a constant value, which is an atomic value, and then it describes a predicate. So you can say that I have a predicate 1, 2. Or you can actually use them as a variable. If it is a variable, what you will have is that you make one of them to be a variable and the other one to be a constant, and the value of x here can be both an input and an output. Okay, so if it's an output, you're looking at all the possible value of x such that this value is 2. If there's no variables, what you will have is something like this, and what you're checking is whether this predicate is inside what is known as a fact. So this is going to be as a fact. Otherwise, it's a relation. Okay, so because each of these elements here can be either an input or an output, you can represent it as a database with a tuple. So let's say you have a tuple of students, and then this is the cap. Yeah, it was a long time ago, but I used to get 5.0. Actually, no, I never actually got 5.0. It was, I've never been that good of a student. But yeah, so let's say, oops, the age is 21. Okay, so then in a relational database, what you want to know is that if I'm giving a tuple such that this one is empty, can I find everything with a value that I give? So let's say this is 5.0. Okay, and as a relation also in SQL, I can also give constraints such that greater than 20. Okay, so this one means that it's equal. So now it's a relation. I want to find all this question mark value such that the grade is 5.0 equals to 5.0 and the age is greater than 20. So then it will just find me all the tuples that uses that. Okay, but in the case of Prolog, they have only one algorithm, which is the unification algorithm. In SQL, you have many different implementations. But this is the reason why it's called a relational database. The other thing is that there was quite a few questions asking this. Why will the referencing and the reference relation be the same relation? What is the advantage of this? What is a use case for this? Well, this is related to the reason why a foreign key can be null. And imagine this. You are designing the Java programming language. You know that everything must be an object, well, except for primitive data types. But every object, every class that you create must have a superclass, except for one particular class, which is the object class. So if I create a table consisting of a class and the superclass, my superclass must belong to a class. Okay, so in this case, this particular attributes actually needs to reference this. Right? And then we have your the superclass of everything, which is the object. So to insert the object class over here, it does not have a superclass. The only way you can insert it is if this is a null. All right? So now for everything else, let's say you have a string here. The superclass of a string, let's say, is an object. This one is valid. Okay? So that's why the referencing and the reference relation can be the same relation. And this is why you also need the null. Okay, so any questions on this? There's one advantage of this, is that you are guaranteed, if you just insert it one by one without updating anything, you are guaranteed that there's no circular dependency between classes. No class can both be a superclass and a subclass of another class. Okay, because you have to insert it one by one. If you don't allow an update, that means every insertion must only reference everything above it. So yeah. So those are one of the possible reasons why the referencing and the reference relation can be the same. Okay, so let's start with an announcement first. The tutorial starts tomorrow. For those of you who has not gotten your tutorial class yet, just go to any tutorial, except that you need to check for the capacity. Now, unfortunately, the room has kind of a fixed capacity. We cannot accommodate more than 23. So if there's already 23 people in that tutorial group, try not to go into that tutorial group. Okay, you can check in Luminous how much is the current capacity. And because some of you has not gotten your tutorial yet, so there will be no presentation for this week. There's one person who is in the 8 a.m. tutorial. And because there's only one person, I'm actually thinking of closing that tutorial. Okay. Again, this is, I'm not sure who it is, but for the benefit of you, otherwise you'll be presenting every week. And you'll be presenting practically all the questions. So yeah, so probably we'll chat later about that. Another reminder is that the assignment 1 as well as the project team registration is due this Saturday. I will open the project registration folder tomorrow. You can register your team if you have 4. Even if you have fewer than 4 and you can't find any more team member, you can just register it. I'll try to not split you up. But of course, if everybody come up with a set of 3, then I will have to split some of you up. It will be done in a pseudo-random way. So I will use a random number generator to try to split, to choose the group to split and to choose where they go. Okay? But I'll try to at least observe your preference for the group. So only one person in the group need to submit the file. So just submit the file. Just put the header, the file name as your user ID. Okay, so it will definitely be unique, and that file should contain all the team member name and user ID. It's the one that starts with E. Okay, and this is because of the PDPA. We can't use your metric number except for anything that is related to the grades. Okay, so just use your user ID. Okay, you do not need to be in the same tutorial for you to be in the same group, but if you're in the same tutorial, it will definitely help during the presentation. Because the presentation is likely going to be held during one of the tutorial. So if all of you are in the same tutorial, then it will, it's definitely that all of you are there, right? But if you can't have everyone in the same tutorial, then we just actually need at least one of you to present for the demo. Okay? So there will be two demos, the alpha demo, which is just to give us your progress report, and the other one is the final demo, which is at the end of the semester. At the very least, one of you has to be there to give the presentation. Okay, and lastly, I'll be holding a help session this Friday, 3 to 5 p.m. So unfortunately, SOC is almost all the rooms are fully booked. So the slot that I can get is currently 3 to 5 p.m. at seminar room 10. So it's at Com1 building. Behind the glass door is at the back end of the seminar room. What I'm going to go through for this help session is most likely going to be if any of you are still having problem with the installation of Postgre, you can come. If you have problem with installation of Exemplify, you can also come. And then if we still have time, then we can go through the relational algebra slowly. Okay, but I will, because there is a 2-hour session, I will try to dedicate at least half an hour or 1 hour to help you install everything you need. All right? So, any questions on this? So I will also upload this announcement separately on Luminous, and I'm just going to create another announcement. All right, so you can see it later. For our lecture today, we're going to look at SQL. So if you are trying to follow, hopefully you have already installed PostgreSQL that has PSQL. And then we're just going to look at the code later, and then we'll try to run it. So this is what we have discussed last week. Integrity constraint, key constraint, foreign key constraint, relational algebra, and so on. Okay, so this is the overview for today. We start with null values. This is self-read, self-read, self-read. Okay, so null values. Let's start with the simple one. Okay, so SQL uses a three-valued logic. You have true, false, and unknown. True kind of corresponds to this notion of correct. False is incorrect. Unknown here is actually just a null. Okay, null and unknown are kind of interchangeable most of the time. So we start with the simple one. If you ignore all the unknowns here, what you will have is basically just this, false, false. And you should be able to fill it in. Okay, so if you just remember your 1, 2, 3, 1, you should know what false and false is. Okay, so that's false. And here means that it will only be true if both x and y are true. So the only part where it's true, ignoring all the unknowns, is this. Okay? And for the or is true if any one of the x and y is true, or if both are true. So the only part where it's false is if both x and y are false. All right, so if you just look at the part that we should know, then this is what it should be. Okay, so you look at the values for the not is just looking at the value of the x here. So try to fill in the blank here. Let's try with a demonstration. So again, true means it's correct. False is incorrect. Unknowns means that you cannot, you do not know any information about it. So let's try some simple tests. So I get this. I want you to guess the value. I have 3 possible values. This is for true, it's in blue. This is for false, F. Okay? And for unknown or null, I'm using green with a question mark. Okay? So the question is actually simple. Right? If I'm showing you 2 values and we look only at the AND operation, is this true or false? Okay, how many of you say it's true? How many of you say it's false? Okay, good. At least you're not sleeping. So now, let's make it more interesting. If I cover something, you do not know what is underneath it. Okay, so let's see what this is. Okay, so my claim is that if you conjunct these two, the result is true. How many of you say it's correct, that the conjunction of these two is true? How many of you say that the conjunction of this is false? Okay, since none of you are decided, so let's see what's hidden behind this. Okay, so what's hidden behind this is actually this. Okay? So then the result should be true, right? But because you do not know what it is, you can't infer any information about it. Okay, so that's what unknown means. You do not know what it is. On the other hand, if I ask you the same question again, this time saying this. The conjunction of these two is true. How many of you say it's correct? Okay, so now, the conjunction of these two is false. How many of you say it's correct? All right, good. So, given this information that is a false, you already have a false, right? It doesn't really matter what this one is. The result is already false. So, you are right in saying that, that this one is actually false. Because one of them is already false. It doesn't matter what the unknown is because you do not know what it is. It's going to be false anyway. Okay, so that's how you can think about the unknown. Okay, you do not know what the information is. You just try to think whether it's either true or false, whether you can infer any information. And again, similarly for the OR, I can ask you that, well, one of this is true. Okay, because it's true only if one of this is true. So I can say that, well, my claim is that one of this is true. Okay? So now you can see that, well, it doesn't matter what this is. That claim is already correct. Which means that if you translate that to the null values, the true with the unknown is true. Alright? And in the case that you can't know any information about it, for instance, true and unknown here, the result of it cannot be known unless you know what the value of the unknown. Okay? And because it depends on the value of the unknown, then you say that, yeah, I need more information. So that's simply another unknown. Okay, so that's the null values. So if you only look at the AND column, this will be the result. False and unknown will be false because one of them is already false. Unknown and unknown is unknown because you don't know anything about it. Unknown and true is still unknown because the value can change. It depends on the value of the unknown. So again, for the OR it's the same principle. And for the negation, it's also the same principle. If you do not know what it is, you cannot negate that value. All right? So that's a simple demonstration of what a null value is. The other way to actually think about the null value is, if you do not want to remember this table, what you can also do is you just put the null as either true, as both true and false. Right? If the value is different, when you put true, when you put the unknown as true and when you put the unknown as false, then the result should be unknown. So what I meant is that I want to know what this is. False and unknown. The way I can answer this question is that if I do not want to remember the table is the unknown can be either true or false, so I can say that false and false. And what is the result of this is false. False and true. And the result of this is false. Okay, because this does not change, then the answer must be false. On the other hand, if I say that f or true and unknown, again I can do the same principle, true and true. I make the unknown to be true and I make the unknown to be false. This one is true and this one is false. Now they are different. Because they are different, you cannot know what the final value will be, so it's basically just unknown. Okay? So that's how you can think about unknown values. So any questions on this? Now we look at what kind of operations you can do with unknowns. And that's already the kind of result that you will expect. When you compare two values involving unknown or null, the result will be unknown. Again, because I can demonstrate again with something like this. Okay, so I say that these two values are equal. Then you can easily see that it's equal. Right? But if I cover one of this, and you do not know what's inside, my claim is that these two values are equal. If this one is covering the value of 1, then yes, this is equal. But unfortunately, this one is 7. Okay, because you do not know what value this is, then the answer must be unknown. Okay, so that's the reasoning behind the operation involving null gives you unknown. Now, a slight distinction between unknown and null is that when you do a comparison, what you expect is either true, false, or unknown. Unknown can be thought of as a null, but there's a slight difference. The slight difference is the data type of it. Think of unknown as having a data type of Boolean. It can replace anything that is Boolean. So it's unknown. It's neither true nor false. But when you're looking at arithmetic value, the result should be null. So that is why when you have unknown value plus 20, the result is unknown, but it's treated as the unknown kind of null, the null kind of unknown. And there's a reason why there's this slight distinction. And that is because if you try to chain things, you should not be able to chain things like this. 10 less than x less than 20. SQL does not allow this, even though arithmetically this is fine. And if you use Python, this is actually okay. But the data type that you get from here is actually nonsensical. In the sense that, well, this give me a Boolean. You cannot compare Boolean and integer. Okay? And again, in the same way that this one, if this one is a null, the result is Boolean unknown. Unknown is not null, so you cannot say that null less than 20. Okay? So that's why there's a subtle distinction between that unknown and null. So yeah, so if it's arithmetic, the result will be null. If the result is if the operation is comparison, the result is unknown. Okay, so if you try to fill in this example here, this is what you will get. There is something that is very, very interesting over here. If you look at the middle two, remember the x is unknown, right? X is null. Null equals to null is unknown. Null not equal to null is unknown. So this is the symbol for inequality. So null is not equal and also not equal to null. Okay, and again, there's a simple way to check using the demonstration is that, well, if I cover this one now with a question mark, can you tell me that these two are equal? So there's no way you can tell me that this is equal. And also, can you tell me that this is not equal? So because there's a possibility that this is equal, and there's a possibility that this is not equal, both questions, whether it's equal to null or not equal to null, gives you unknown. Okay? So this is something that is critical. We can actually kind of try to treat null as a value, which I will show later. There is a different instruction if you want to kind of treat null as a value, in the sense that null, a different operation with null, the different kind of equality with null give you true. Okay, so there is a way to treat it as the same. But if you are using equal, if you're using the equal sign or the not equal sign, then the result is unknown. So yeah. And that is the reason. So we cannot say two null values are equivalent, or we cannot say that two null values are not equivalent, because they can be anything. The chances of it being equal is smaller than the chances of it not being equal. But that's besides the fact that we will not know what it is. So other kind of operations that we can do with a null value is that we can check whether a certain variable is null. And this is kind of straightforward. You use the is null comparison. Okay, so then the answer to this is basically x is null, so this is definitely going to give me true. Okay, if x is not null, and you ask whether x is null, obviously this is going to give me false. But if x is null, and you ask whether x is not null, then this is false. If x is not null, and you're asking whether it's not null, then this is obviously true. Okay? So this is a straightforward comparison. Now this is the part where we can use another operation to actually compare null values as if they are values. And the operation is distinct from. Okay? Two null values are not distinct from one another. They are not equal, but they are not distinct. Okay? So if I have this y as null, and this is as non-null, this one is null, this one is non-null, what do you think the answer will be? Okay, so I said two null values are not equal, but they are not distinct. Okay, so this one is actually false. Right? Null and non-null are actually distinct, because you know that one of them is non-null. So this one is true. This one is true. Now then what happens if both are non-null? Will it be true or will it be false? Okay, you do not know what the value of the non-null is, right? So what you're going to look at is the actual values itself. Since it is non-null, you know what the value is. Then just compare the value. So the result of this is actually equivalent to the non-equality. You're saying that two non-null values are distinct if and only if they are different. All right? So any questions on this? Yeah, and the reason why we can do this is because those values are not null. So we know what is the actual value. So we can just reduce it to this different operator, the non-equality operator. Right, so that's the null values. Any questions about null values? Right, so let's move on to the SQL. How many of you knows about grammar? There's this notion of grammar in programming language. Like you have if something, else something. Right? So that's a grammar. You describe, the grammar is a language to describe how to write a programming language. So in this case, hopefully you kind of know certain rules about grammar, because we're going to use them. First of all, to describe a command, commands are not part of the programming language. It is for human to read. There are two ways. One is that you can use two hyphens, and this is a single line command. So in C, JavaScript, Java, you have this. In Python, you have this symbol. But SQL also supports a C-style commands where can be a multi-line. So this symbol is a combination of two symbols, the backslash, slash, and a star. To close it, you just give a star and a slash. As long as you cannot find the star and slash, it will not close the command. Okay, so there are two styles. For the exam, I was told by Prof. Chan, because last time we also used the digital exam, you should use the C-style commands. Because the file that we download, if you use Exemplify, is apparently going to be appended as a single line. Now, white spaces are not important in SQL. But new lines can be important, especially if you have a comment. This one will treat everything until the end of the line as a comment. If your code is given as a single line, then everything else after this is considered as a comment. So in exam, you should use this. All right? Okay, and just to recap, the rule of the grammar is kind of the same as if you're going for other modules. Optional components, square brackets. If there are choices between those, we use the vertical bar. If you need certain choices, but this is not optional, so you use this curly bracket. Okay, if it allows an arbitrary number of repetitions, it will be a dot dot dot. all keywords are in uppercase and variables are in lowercase and bold. Okay, so that part actually SQL is case insensitive. You can actually put everything as a lowercase. But to make things easier, every keywords I will use uppercase. So let's see how this grammar can be used in practice. The first kind of SQL that I'm going to teach you is to create a table. This is the syntax on how you can create a table. Again, the keyword here is create table. So let's explain this a little bit more. This part is optional. There's a keyword if not exists, and that is optional. All right? So after you say that you want to create a table, the second part here, table name, is a variable. You can put it anything. So I can create a table called students. Right? And then this part is part of the language itself. You have to give a round bracket. This part match with this. Basically, everything in the middle here is actually optional. So the simplest kind of table that you can create is a table without any attributes at all. To drop a table, you can just say drop table. That's the keyword. And then this one is optional. And then you just give the table name. There's something that I forgot here is that every statement will end with a semicolon in PostgreSQL. Okay, so let's look at what is the simplest one first. The simplest creation of a table will be something like this. Everything in the middle is a comment. I can create a table without any column at all. So let me show you. Okay, I have too many things here. But yeah, I can erase all of this. So let's create a table. A student table that really has no attributes at all. Okay? If it is accepted, then you will see something like this, that this create table is successful. And if you list out all the tables with a \d, you will see that students is there. Okay? Now again, PostgreSQL is actually case insensitive, and in fact, SQL is case insensitive. It's supposed to be case insensitive. Okay, so to drop the table, to erase the student, to erase the table completely, I can drop. Okay, if it exists, I will just erase the entire table and even remove the table completely. Okay, so let's try to create again. So I can put it as a single line like this. And so what I want to show you is that it's really case insensitive. So this one is actually accepted. All right. So if you look at the list of tables, students are there. Okay, so any questions? So again, when I drop, I can even give this one in uppercase because SQL is case insensitive. If I try to drop again, because the table does not exist, I will get an error. So yeah, so that's the simplest kind of table that you can create. So this is what I said before. The SQL is actually case insensitive. You can, the keyword here, even though I wrote it in uppercase, you can actually use lowercase. Now, if you want to specify constraints, we've learned about a few types of constraint. The easiest one will be the domain constraint. The domain constraint restricts the values that you can insert into that particular columns. The way we specify the domain constraint is by specifying this data type. There are different kinds of data types. Some of them are familiar. So these are the lists of data types. You have normal things, Boolean, integer. For float, you have float 8. It's 8 bits. Now, SQL also have an arbitrary precision arithmetic. If you say it's numeric, it's basically arbitrary precision floating point number. It is very, very precise. It's just that you have to give a way to compute that value. But the value that you store might actually be very, very large. So if you want to limit that such that every size is the same, you can actually give numeric PS. You can specify how many parts are in the decimal, how many digits are in the decimal, and how many digits are in the fractional part. So if you give numeric 5-2, the precision that you can get is basically 5 digits in front and 2 digits at the back. Okay, so you can read this up on your own. This will be important for your project because we do not want everything to just be an integer. But for midterm, usually everything is just going to be integer. Midterm, assignments, everything is just going to be integer. It's going to be just simple domains. All right? You can also create your own data type. But again, I'm not going to teach that. If you need your own data type, you can read it up online. Right? So any questions on this? A possible table here is that I can describe what are the attributes that I want to have on my table, as well as the data types. So student ID here is treated as an integer. Okay, the name usually is not going to be an integer. The date of birth is going to be date. Okay? And if I have a table created as this, these values are all going to be accepted. Every values within this table satisfies the domain constraint. All right? So any questions on this? You can try opening up the lecture03.sql, and then you can try to play with this as well. The other kind of constraint that we talk about, besides the domain constraint, was the key constraint. The key constraint, there are two ways to actually specify those. The first one is what we call as a column constraint. The column constraint is specified when you declare the column or the attributes. Domain constraint is a column constraint. It's kind of part of a column constraint. You specify it when you specify the attribute. It's just that the data type here, which is part of the column constraint, is kind of non-optional. You must give the domain. You can give an additional column constraint. That's why this part is optional. Right? And you can give as many column constraints as you want. That's why there is this ... You can chain them. Okay? Now there are a few kinds of key constraints. We talked about this before. The main one that we were going to discuss in this particular part will be primary key. The keyword will be primary key for obvious reason. Okay. So if you want to set certain attributes as a primary key, there are two ways to do this. One is that if you know that there's only going to be one attribute that is going to be the primary key, you can specify it as this, as part of a column constraint. So you know that this one is your primary key. Okay, so remember what primary key is. It means that the value of the student ID will uniquely identify the entire tuple. Okay? So in this case, I'm just putting the constraint saying that the student ID has to be the primary key. It has to uniquely identify the rest of the tuple, the rest of the attributes. And what it also means is that means the way for the primary key to be violated is that if I can have a function f with the same value of x and a different value of y. If I have this two, let's say minus y, then x cannot be a primary key, right? Which means if I specify that this is a primary key, I am going to disallow this property. And the easiest way to disallow this property is that every value of student ID must be unique. Right? Remember, that's how we decided that the grade for that particular relation instance was a possible primary key, because all the values inside are unique. So if the value is unique, then it can be a primary key. And again, it cannot be null. Okay, so primary key is simply that the value cannot be null and it is unique. Now, if you allow multiple attributes to be primary key, then you need a different way. Okay, but before that, let's see what kind of table, what kind of instance this table creation allows us to insert. So if you have this, there's only a slight difference between the previous table, and that is this. These two values are the same. But we say that student ID must be the primary key. So now we have a violation of a primary key. So one of these must be wrong. Okay, so those two lines actually violates the primary key constraint. A possible table that does not violate the primary key constraint is this. Okay, so every value here in the student ID is unique. If I add something like this, then this one is also incorrect, because a primary key cannot be null. All right? So any questions? Okay, so the other way is that if you have multiple attributes as your primary key, then you have to give it this way. You specify that this pair, the pair of SID and CID, are going to be my primary key. Okay? And if you look at this table, there are two rows that violates this constraint. If you look at this, it's the same SID and CID. The pair are the same. You have a pair of 3118 and 112. So those two violates the primary key constraint. Now notice that this does not violate the primary key constraint, because our primary key is a pair. So that pair must be unique. All right? So any questions? So if you just remove one of them, this is going to be a valid instance. It's going to be a legal instance. Okay, so another kind of constraints, another kind of key constraints that we have before was the foreign key. For foreign key, we have two conditions. One is that either the value appears as a primary key on a reference relation, or it can be a null. Okay? This is also called referential integrity, and there's two keywords: foreign key and references. Okay, references is going to be used. Either you specify as a column constraint or a table constraint. So I'm going to show both methods at the same time. This is a column constraint. This is a table constraint. When you specify it as a column constraint, you don't have to say there's a foreign key. You can just say references something. Okay, so SID is going to reference the student ID from a student's table. The CID is going to reference the course ID from the course table. Okay, so again, we can look at an instance of it. This is currently not a legal instance. And the reason why it's not a legal instance is if you simply look at the SID columns, you have this. 1111 is not available over here. Because what we said was the SID references the student ID. And then CID references the course ID. Okay, so the last row is invalid because 1111 is not appear in the student ID. For the second column, you just look at it again. 311 does not appear here. 313 does not appear here. And that's it. Okay? So notice that I never cross out any of the null, because null can be used as a value inside the foreign key. So only those three are invalid. Okay, so the null here is fine. So any questions? Okay, so again, to see why the null is fine, you look at the definition itself. The definitions say that either it appears as a primary key in the reference relation or the value is null. Okay? Now this is where something interesting is going on. So far, this particular row referenced this particular row. And then this particular row referenced this row from a different table. You can actually say that a pair references another pair. And this is how you specify that. You have this pair must specify this particular pair from the student course table. So okay, so assume that there is a table called student course. So you have a pair referencing another pair. And this gives us more leeway in giving out what's the reference relation. For instance, again, if you look at this, if you only look at the individual row, you will find that for the CID here, because the CID references the course ID, you may think that this one is not allowed. Okay? If you look only at that particular row. However, because what you have to look at is a pair, both of them view as a pair is actually fine, because one of this value is null. All right? So again, you look at the definition is that it either appears as a primary key in the reference relation or the value is null. If you have a pair, if one of the values is null, then it's fine. So this is accepted in a weird case. Okay, so let's erase all of this again. So what you have to look at is a pair of them. So this pair appears over here. This pair does not appear. So this one is wrong. Okay, this one appears. This one is null, so it's fine. This one is null, null, null. This one does not appear. All right? So the other thing is that, so let's say I change this value. Okay, so let's cross out everything that is false first. So it's this one and this one. Okay? So those are the two values that violates the foreign key constraint. Now, let me ask you this question. If I have this value, this tuple, 1, 4, 2, 3, 1, 1, 2, and then 5.0. Is this a valid row? Okay, so again, you need to look at the pair. Individually, there exists a value. So 1, 4, 2, 3, and 1, 1, 2. But they never exist as a pair. Okay, when you specify that this particular pair references another kind of pair, you need to look at the pair as if they are a single value. Okay, so in this particular instance, this one is invalid, because the value is not null and the pair does not exist in the student course. Okay, so when you have this foreign key constraint, when you update the table, there can be violations. When you insert something, there can be violations. So that's what we have been doing. If we try to insert this tuple into this table, there is a violation. We cannot insert. But if you try to modify the student table, we may accidentally create a violation. For instance, if I change this to 3119, then this row violates the foreign key constraint. Okay? What can I do with that? So what can I do is that I can specify what to do on this kind of operations. If I try to delete something, I can specify an action. If I update the value from 3118 to 3119, I can specify what's going to happen on this. And that is going to be specified by my action. The actions are going to be limited. These are the possible actions. The default is going to be no action. Okay? Which means that you're just going to reject whatever updates, whatever insertion you make. You can restrict such that that checking cannot be deferred. Okay? But we're not going to talk much about deferring constraint checking here. It will be on future lectures. Cascade means that you propagate. For instance, this one, if I cascade the update, once this one becomes 3119, this one will also become 3119, 112, 4.0. So that's what cascading the update means. If I cascade the deletion, this value is going to be deleted. All right? If you want to set into the default value, you have to specify what the default value is. You can also set to null. Again, if you set to null, it does not violate any foreign key constraint because you allow to have null. It may violate other constraint. If you expect those values to be primary key, then you cannot set null. Right? Because primary key cannot be null. So you need to be careful on what you can do over here. So let's have a kind of a quick example. Again, let's say we don't specify this as primary key, so that's why this one is not underlined. If you try to delete 3118, we allow this deletion to proceed. So I will try to delete this. It's not exactly that feasible. So I try to delete this. When I try to delete this, I notice that, well, this one is going to be violated. So I'm just going to set the SID to null. Once I set it to null, so this one is set to null, this one is try to delete, then I can safely delete that value. Logically, you can think of it that both happens at the same time. The update and the deletion happens at the same time, logically. So yeah. Now if you try to change 1423 to to 1444, again, there's going to be a violation. So the only way to make it to be non-violation is that if I have an update cascade and that changes is going to be cascaded into the referencing relation. So this one is updated into 1444, and then at exactly the same time, or logical time, this one is also going to be updated. So now you have both as 1444. Okay? So it's good to think that both happens at the same time. Because if it's at the same time, then there's no violation that occurs, before or after. Okay? So last one is that you can specify other kind of general constraints. So these are the kind of general constraints that we can specify. You can specify that certain values cannot be null. You can specify that certain values must be unique. Again, you can the very last one is the very general constraint. As long as it evaluates to false, you will reject any insertion. You have the keywords. So one thing to note here is that, because we're kind of running out of time, I'm just going to release you at 5:30. One thing to note here is that these two, not null and unique, if we specify that a certain value cannot be null and they must be unique, we are actually saying that value must be a primary key. Right? Because if it's unique, then it will fully identify, it will uniquely identify the tuple. Okay? So if you specify a certain property as both unique and not null, you're saying that particular attribute can be a primary key. And that is what we call as a candidate key. So if you have a candidate key, the way you specify a candidate key is that you specify that it's unique and not null. You can specify as a pair. This particular pair must be unique, and this particular pair must be non-null. Okay, so I'm just going to show you how it is. If you specify that this one is not null, you can use this way, or you can check. You can check that this one is not null. If you wanna know that if certain attributes are unique, you can say that this one is unique. Okay, so now these two violates, because Alice is not unique. And this is what you check. You check that for particular attributes, whether or not it's false. If you want to check that a pair must be unique, you can give this, a table constraint. So this pair must be unique. So this Alice does not violate the constraint. But this pair, these two pairs, violate the constraint. All right? So if you specify it as this, as a table constraint, as a column constraint, what you will check is basically all the attributes there must give you a unique value. It means that it is not unique if any one of the attributes value is different. So that's what you are basically checking over here. Right? So the very last one is the general one. As long as this one evaluates to true, you will accept the insertion or the updates. Okay? So this one, this violates the constraint. So you should not be able to insert that. If you try to update certain values, if you try to update this value to 1999, you will also encounter an error because it violates that checking. Right? So check is very general. So yeah, so that's how you can do a general constraint. Okay? So if you want, you can say like, if your database is created at, let's say NUS. NUS is built in, is it 1800? 1805, 1905, right? NUS is built in 1905. So if you create a database of all NUS students, you might want to check that the date of their enrollment to NUS must be greater than 1905, than the year 1905. So that's a possible check that you can think of. So yeah. So any questions? All right, so that's it for this week. So we can't finish the slide. So we'll just continue on from this for next week.
Our team has 5
Yeah, so just try to do as 5 first, then in that particular case that I might need one of you to. No, it might be possible. So it really depends again on how many groups that we're going to have in here. So how many people are going to enroll. So I'm trying to get 4 people. Now, if in the case that everybody has 4 members and then there's only 1 person left, I cannot just conjure 3 people. So I'm just going to put that 1 person into just any one group. I'm trying not to have 3 people. So 5 is quite okay, usually. Yes, stick to 5 first, and then I will try to accommodate for that.
Okay. And what like when will we know that when will the six be finalized?
So it's going to be in the middle of the week. I'm going to come out with a check whether everyone already has a group and that nobody is doing that. Typically 1 in 4, right? Because if there are 4, actually it's about 3/4. If there are 3 people not having a group, then I'm going to have to split that 3 people into 3 groups so that 3 groups will have 5 people. But it's typically 3 in 4. The only way your team is going to be split up if you have exactly multiples of 4.
Otherwise it will be
Yes. You see, it's not multiple. Yeah. Unless if there's also the other possibility that if there's too many groups within 5 people, but I'll try to respect your choice first, because we try not to have